Good morning, everyone. Thanks a lot for coming to our talk called the Hitchhiker's Guide to Observe Java Applications in Kubernetes. Just one question up front. Who of you in the room was at my OpenTelemetry lab yesterday? Oh, there's one. OK. Thanks for coming back. OK, so let's quickly introduce ourselves. You want to start?
Sure. Bonjour, je m'appelle Tiffany. Mon français est très mauvais, donc je vais continuer en anglais. But yeah, so if you still use Twitter or X, some people... Actually, I'm curious, who still uses Twitter or X? Almost no one. OK. All right, well, if you do, mine's there on my website. If you are going to any of the other DevOxes or other things, if you are hiring for developer advocacy, please talk to me.
OK. I didn't prepare any announcement in French. I have to apologize, so I'm going to stick to English. My name is Matthias. I come from Germany, from Stuttgart, actually not so far away by train. It's only like 3.5 hours from here. I work at a company called Novatech. We do like enablement of clients on their journey towards a cloud-native software development world. So I teach and consult as good as I can. Besides that, I also teach at universities in the area of distributed systems and modern software architecture. And yeah, some of those bits in the talk kind of originate also from that area. Now, yeah, I still use Twitter or X, but most of the time you will probably find me active on LinkedIn nowadays. So things kind of shift over there at the moment. All right. We have a copy of those slides on Speaker Deck. You don't have to take the photo now. I show it again at the end, so if you like the talk, you can take the photo then. It's probably not going to be the latest version. We made some updates before, so but we're going to upload it right on that link later on. So yeah, in a nutshell, what is this going to be about? We're going to talk about observability in various extents. What can this mean in the area of Kubernetes? Like, how can you approach what's going in and on and around your cluster? There will be a bit of a focus on Java or like JVM-based technologies, but not exclusively. But we're going to get into these details later on more. So I'll hand over to Tiffany.
OK, so there's probably a question of, well, why did you end up coming to this talk? Hopefully, it is because you have at least some idea of why you think observability will end up being useful. I guess a question is, who here has used Kubernetes before? OK, decent chunk of the room. OK, cool. So you probably found out that at least at some point in time along the way that things can get pretty complex with that, and especially trying to figure out if something goes wrong, of like, why is this thing going wrong? We're going to go and show a bunch of different tools and like different ways that you can get more observability into what is happening on your Kubernetes cluster. OK, so you can kind of see here that there's like two different layers. You have your application, and then you also have your infrastructure. Before we like dive into things pretty deeply, we're going to go a little bit into some of just like a little bit of Kubernetes concepts. It'll be familiar to a good chunk of you, but just to make sure that everyone is at the same level. So yeah, basically with Kubernetes, you have your nodes, which you basically have your applications that are running on, and those applications are running containers, and they could be a bunch of different languages, and you can kind of basically decide, hey, what am I going to end up running there? So basically, you have two different pieces for your infrastructure. You have your control plane and you have your worker nodes. Depending on where you are running your cluster, you may or may not have access to your control plane. So say if you're using some sort of managed service, the ability to get like metric data, et cetera, will depend on whatever provider you're using. And then you have access to your worker nodes. So then we also have the level of whatever your applications are and your workloads. So those, again, can be in, say, different languages. You could be using different frameworks. Depending on what kind of application you have, the type of monitoring you might have might be different. But basically, independent of all that stuff, you kind of want to know, hey, how are my workloads doing? Is everything working as expected? And if it's not, how do I figure out what is going wrong? So not only do you have those level of things that you need to worry about, you also have like your Kubernetes API objects. You have things like your services. You have your replica sets. You have your deployments. So basically, between having like your applications that could be potentially running in different languages, Kubernetes with all these API objects that you have to go and be able to actually understand, there's just a lot of information that you need to know to be able to actually like fully dig in deeply to figure out what is happening and how to figure out what is going wrong, or is it actually going the way I expect it to. So to kind of just like summarize, so basically, yeah, you have your infrastructure that you have to worry about. You have your applications that you're running, potentially in different languages. And then you basically just need to, and it's not just like, hey, what's happening with this specific like application that's running. It's also, hey, how is the connectivity working between different pieces? Like, is my application actually able to talk to my database, for instance? Like, there's just so many different parts that you need to worry about, especially dealing with things on Kubernetes. So that makes it pretty tricky. So there's like all these different levels that you can go and query data from to get metrics. So like, for instance, you could be talking to the API server. You could be talking to the nodes that you have. You could end up having a sidecar that is running inside of your pod to get metrics. You could be getting metrics specifically from your application. We'll be going into all these different like areas that you can get metric data from as we go through this talk. So basically, there's just like various points of where you can inspect, and basically those give you different types of metrics depending on what you are looking at. Not only is there a difference in metrics, there is a difference in like what overhead you might have or configuration costs. Like, for instance, if you are dealing with your nodes, you don't have to go and be like, hey, I need to go and specifically change my application. But depending on where it is, you may have to change different things, rebuild stuff, and you just kind of need to end up deciding what am I willing to give to get something in return. So basically, there are a bunch of different tools out there. For all I know, someone in this room may have been working on one of them. But basically, this is a slightly older version of the CNCF landscape. Who has seen this before? OK. So yeah, basically, I guess it has even more stuff because it just keeps growing. That's one of the big things, is just like I don't know if there's any good way to keep track of everything that is happening here, but this the circle over there is for observability. So if we look, this is a newer screenshot, you can tell it looked a little different, but basically there's still a bunch of stuff there. We obviously can't go into all of those things, but we'll go into some of the ones that we have used or are familiar with. And of course, you can feel free to go look up the CNCF landscape and see. And there's also different levels of like whether it's incubating, et cetera, that you can look at to see who maybe has been using it more and how mature something is.
All right, thanks. So, I mean, yeah, this is a bit of the dilemma that we have with Kubernetes here. So, ideally, we would have like to have one monitoring solution that would give us all the metrics from the infrastructure to the application, and just like one access point how we could install it, that we would not have to make this decision. Unfortunately, it's not like that. So, with this talk, we're gonna kind of iterate over the various levels of observability. So I'm going to start now with the kind of entry level, so to say, using the Kubernetes API. Then Tiffany's going to talk a bit about monitoring on a node-based and on a pod-based kind of level. And then I'm going to close it up and going into the application using tools to monitor that. So yeah, this is where we start. The first level of observability, I mean, this is probably most of you that have raised their hands before are kind of familiar with, because that's basically what you start interacting with when you start with Kubernetes. The most obvious way, or like the entry point, is normally your Kubernetes API, where you have quite a few helpful commands like get, describe, logs, and exec, where you can query information about your Kubernetes API objects. They would give you their status. You can get logging information. So you can already get to a certain point to figure out how is my overall cluster behaving, how are my apps behaving, but you certainly have also limitations there. There are also tools to actually do that besides the kubectl command line interface that most people probably know. So there's some other CLI tools, there's some web tools, there's some fat clients that I just want to browse around real quick. So I've been talking about this topic for a while, and another fact that makes the thing tricky here is like this landscape that we've seen before is also pretty dynamic. So not only new things are coming up, also old ones are going away. So when I talked about this first time, maybe 3 years ago, there were still like tools like VMware Octant, weaveworks Scope, and Lens, and they have all kind of gone into different directions. So some of them have just been deprecated and discontinued. Some of them have turned commercial, and that doesn't make life a lot easier for us. So K9s, as a counterexample, has been all the way around. I also saw it on some of the booths walking in the sponsor area, so I'm always happy to see that one. This has always been a very good friend. So in the last version of this talk, we had like sending in new kits here, but we got complaints from the owners of Headlamp and say they're not the new kit anymore, they're around for a while. But anyway, there are tools that replace the ones that I have just shown and do similar things. So we might have some time at the end of the talk to show some of the things live. For now, most of the things are just going to be like that. So this is like a screenshot of K9s, which is kind of the older people in the room might know, like things like a Norton commander for Kubernetes. It's like a kind of a text-based browser where you can navigate through your API objects, drill into them, query the logs, see the details, and so on. So it can save you quite a bit of time as opposed to using kubectl only. Now, this is an old screenshot of Octant, and this one is from Lens. So technically speaking, you get like a proper UI that you can use your mouse, you can navigate around, drill into some of the objects. I mean, it also allows to, for example, open a shell in a container. And if you do that in a browser, this can be quite handy. However, as I said, those are a bit out of date. Now, Headlamp and Schooner are doing fairly similar things. These are also pretty helpful for people getting started with Kubernetes because in the beginning, you have this like amount of API objects. You don't really know what they mean. And they might just give you a certain categorization. Like, okay, this is a workload object, this is a storage object, and a network object to make things easier for you to navigate around. Schooner is pretty much the same thing in white. I mean, they also have a dark mode, I guess, but it's those tools can only do a certain amount of things, basically which the kubectl allows. Kubectl would potentially be able to do everything in the same way. They just aggregate and make it a little bit nicer. Now, one of the things that I try to highlight here every now and then is the kubectl debug command. So from the people that raised their hands before, who has used the kubectl debug command? Okay, there's a lot less hands. And it has been around for quite a while. But people don't really know about it very much. So kubectl debug kind of works in a way that you can attach a second container to an already running container in a pod. Well, this is as dangerous as it sounds, but it is also as helpful as it sounds. So for example, if you have like a distroless image, where you don't have a shell, or you don't have anything that you can do inside of that image, but you have a failing component in there, and you would like to debug it while it is still kind of, while the process is still alive, you can attach a secondary container, and then all the binaries become available to you. So then you can open up a shell. A colleague asked me if I could place an HTOP in a running container to monitor the threats and so on. So this is a thing how you could achieve that. You shouldn't give this right to everyone, especially not in production. But if you have like a component which needs attention in a critical way, this can be certainly of help. Now, to sum things up, so from this first level, I mean, this is something you get out of the box anyway. You don't need to modify your Kubernetes cluster in any way. You don't need to enable things or install things and change your configuration. You already have that. So this is not intrusive. There's not a lot of overhead. And it's very helpful for understanding Kubernetes things. However, you wouldn't be able to identify a ghost process. You also wouldn't be able to identify those two things are not talking to each other, even though if they should. So it's like a high-level kind of scanning mechanism. Are things okay? So you would obviously see if like pods are failing, or if you have critical errors in the logs or whatsoever. But it's not going to be the end of the story. So before I give back to Tiffany, I just would want to briefly mention Prometheus and Grafana. We never knew where to put those two exactly into this talk, but people told us we cannot do an observability talk without mentioning Prometheus and Grafana. So they are two tools that kind of have been around ever since Kubernetes was around, or pretty much at the same time. So Prometheus is kind of a time series database that can scrape metrics from different resources and endpoints and store them for evaluation. And a lot of the tools that we're going to show later on make use of that. And Grafana, in turn, is like a customizable dashboard that you can put in front of it to visualize everything that you have in Prometheus. So on a standalone basis, they might not be so super helpful, but they are being used as backbone by many different applications. So I'm just going to mention this now, and we're going to refer to it later on again. All right, so this is it for that part, and I'm going to give back to Tiffany.
And yeah, part of the reason of being uncertain of where to put it is because Prometheus and Grafana can actually be used pretty much along every step of the way that we were talking about, like with the various levels of introspection. Like maybe you have it for your applications, maybe it's at the node level, etc. Like it can be used in so many different places. So yeah, we're going to be going into the pod-based side of things. So basically, looking at like, hey, we have our pod that is running on our Kubernetes cluster. We don't need to worry about the other things at the moment. Just trying to figure out how are we going to get some like metric data and such from our pods. So this is a survey that Cilium or like Isovalent had ended up that they did a while ago. So basically, it was asking people, hey, what features of service mesh interest you the most? Some people may have thought that maybe it would be specifically on like security or something like that, but actually the thing that got the most like votes, I guess, was for observability. So I guess this is why we have this here. So I assume that most people already know this part based on the number of hands of who's used Kubernetes, but just to refresh, basically your base layer that you have is or base unit is a pod, and that is just basically a wrapper around your container or containers. So basically, this pod and therefore whatever containers that you have inside of it are connected to your network traffic. So you could also have multiple containers within your pod, and then based on that, both of those containers will be connected to the same network traffic. So like they share the same network address, the traffic that one container can see, the other one can see as well. Therefore, it doesn't make so much sense to end up running two just completely different applications inside of your pod. Basically, what would make more sense is to end up having some sort of proxy, and that this proxy can then go and listen on the network traffic. It can basically see everything that is happening and without having any effect specifically on what is happening with the app. So then it can go and connect data based on this. So it's not super useful if you have it just for, like, say, one application, then you only have data from one. It's a lot more useful if you end up having it in every single one of the pods that you have running. Fortunately, you don't have to go and manually do this, but basically you have that. You have all of your pods running on your data plane. You have your control plane, which ends up collecting all of the data that you have based on that. You can apply policies. You can do things for rules for like directing traffic. You could be like, hey, I want to like have a certain percentage based, etc. And you can see like how long each trip ends up taking versus just like if you only have one little part there. So each individual part doesn't know about the other ones, but your control plane gets all of the data there. So another good thing about this is that it is independent of whatever language or framework you used. So you could have like something that has Java, you could have something with Go. It really doesn't matter since it doesn't have you changing anything with your application in order for that to work. It's just anything that can run on Kubernetes. You can't get app-specific metrics at this level, but you can get all of the network metrics. So it just kind of depends on what level of things that you specifically need. But this makes it really nice because it is completely independent of the application. And as a result, if you're like, hey, I don't like this, or for whatever reason, you can decide, hey, I'm going to pull out the proxy and just go back to how things were before. You don't have to go and manually like restart or rebuild your application. Removing it will cause your pods to end up restarting, but that is kind of the extent of things. And so again, yeah, basically all of that information ends up feeding into the control plane that you have. So now that you basically have all of this information, for some people, maybe you prefer looking at a bunch of like metric data, but now with that, you can actually go and visualize it. So this is an example to-do application that Matthias built, and this is using Kiali. And so basically, like, you can see things like what direction is the traffic flowing. You can see like the percentage. You can see that it's like split between 2 different versions and different things like that. Obviously, it's not like as helpful when you only have like a small application like this. I mean, it is super helpful, but like it's even more helpful when you get to something that gets even more complicated where you have a bunch of things going on. So this is an example from a Spring Pet Clinic app. You can see things like, hey, there's some issue with the Wavefront proxy, and therefore all the red is happening, and there's something going on there. So you can see like just a better idea of like what is going wrong and where are things going wrong to help you kind of figure out where to even start. Because sometimes just looking at a bunch of numbers or just like, oh no, this, maybe you can see that your pod is not running, but like what else is happening specifically. So just kind of to like summarize a bit, so basically like it extends Kubernetes for like some of the limitations in traffic awareness and shaping capabilities. Say, for instance, you have a deployment and you have like 3 replicas of your, like, so 3 copies of your pod. The traffic can be distributed amongst those evenly, and Kubernetes will just handle that. But if you're like, hey, I want to have like 10% to this pod, and I want 40% to this pod, et cetera, you can't do that by default with Kubernetes, but you can do things like that with Service Mesh. Basically, again, you are injecting a sidecar proxy that is running alongside of your application in every single one of your pods. It does not give you application level metrics, and one of the things is that basically you just end up running your things. You don't have to go make configuration changes while you're running things.
One question at this point. Who of you uses a Service Mesh? And who of you uses it also for observability?
Huh.
Okay, oh, that's still a few. That's interesting. Okay, sorry, go on.
Wow, rude, just kidding. Okay, so basically now we're going to go into things like, instead of being on the pod-based level, going into it on the node-based level. One of the ways of doing this is with eBPF. So it has a much longer name because everyone likes acronyms. So basically this is Extended Berkeley Packet Filter, where I think everyone just calls it eBPF nowadays. So basically, instead of observing, say, from your pod level, you're observing at the node level. So it's a pretty, actually, who's heard of eBPF so far? Okay. So at the end of this talk, I'll be like, who's heard of it? And if you didn't raise your hand, just kidding. So basically, it's using a low-level functionality. So basically, you have like your kernel space. So that's basically like where your kernel software runs. Usually, that is a pretty protected environment so that people can't just go and mess things up. But this also means that it's pretty difficult to change. So say you want to update something in Linux. If you go and try just doing that yourself, maybe it'll be, I don't know, a few years till the release comes out with whatever your changes, and that's obviously not going to work in this type of case. So, and things that like you normally are interacting with is over on the user space, so you can see like your SDKs, your libraries, and your tools. One way to kind of like view this is like you can kind of think about it how JavaScript is in a web page. It's basically like where you can run your custom code, but you can't go and harm the environment that you have, which is important. So in the kernel space, basically you can interact with like kernel events such as like network events, and then those get sent over to the user space. So when dealing with like Kubernetes, we have like you have your top layer where you're dealing with like your containers, etc. At the bottom, you have your operating system, and most of the time, that is using Linux. So that's where eBPF technology ends up being helpful, since it is using Linux. So basically, you just have like all these different levels of abstraction, and then we're specifically worrying about it down there. So it's similar in some ways to like your pod-based service mesh. You have your control plane, which ends up aggregating all the information. But instead of collecting information on each one of your pods, you end up collecting it on every single one of your nodes. Ideally, you end up having fewer pods, in fewer nodes than you do pods. Might be a little strange the other way around, but basically then you have less that you specifically have running, using less like hops and latency. So kind of like how we were looking at with the service mesh, you can also have visualizations. So this one is with Cilium's Hubble UI. And so this is also with Spring Pet Clinic. You can see like the direction that traffic ends up flowing. You can see the different components that are all talking to each other. What you don't specifically see from this is like, hey, what are like the response times? What are the throughput, et cetera? That doesn't mean that they don't exist. It's just not something that you can specifically see in this UI, unlike some of the things that you could see with Kiali. And if we get extra time, we can actually poke around with some of that. But it does collect that. So basically, you instead can go and use Grafana and basically, you have Prometheus and Grafana, and you can actually go and see things like the response time for overall requests. You can see a specific trace view. If you did go to Matthias's, I guess the one person here, there was going into traces for that, which we'll go into a bit later. It's more specifically for applications. But basically, like you can see a bunch of different data for these, both using like the traditional like service mesh with your pods, and then also using it at the node level. So the eBPF like landscape is continually growing. I think it just like over time, more and more people have been hearing about it. More people have been doing things for it. If you go to the ebpf.io/applications, there's a bunch of different applications that are out there now that are using eBPF technology. There's things like Pixie, Deepflow, and CubeShark. These are not obviously the only ones, but you can see that they can give you various levels of information for that. So basically, to kind of like summarize for that, instead of adding some sort of proxy component that is running alongside of your application in every single one of your pods, you have that at a node level. So basically, then there's lower latency since you have fewer hops versus doing it with like having a pod. It uses a low-level functionality that's for Linux that's basically leveraged specifically for the things that we want to do with Kubernetes. And like as I was just mentioning on the last slide, like it basically just keeps growing. When we first created this, there wasn't so many applications that you could use that have eBPF, and now it's just continuing on and on. If you want to hear, if you know French, which actually, who here doesn't speak French? Okay, cool, same. All right, so basically, yeah, I guess most all of you could go. It's right after this talk, and Mohammed is basically diving into eBPF in French. And if you want to hear a lot more about it, you should definitely go to that.
But please tell him you heard it here first. Like. All right. Okay. Thanks. So yeah, as you can see, we're going like further and deeper into the cluster and narrowing down potential problems. So if you use like Kubernetes API to like on a high level way sense or like get awareness of something might be wrong, we can use the two different service mesh types for isolating the problem and say, okay, I know something is slow, but I don't know where it is exactly. But then if I have all the network information, I can say, okay, I can track it down to this certain component, and I can see this might be the root cause of my problem. And now I want to get deeper into that. So this is basically the final step here, where it goes into application-based observability. Of course, this also changes a lot of things on how you approach it. I mean, as Tiffany has said, if you do like service mesh, you can pretty easily like swap the sidecars in and out. It will trigger a restart, but that's the only interruption that you have. You don't need to modify anything in your containers. With eBPF, you only instrument the nodes. You do that once, and once this is set up, You don't need to specify, I want this one or I don't want this one. Just everything will flow through that network, and you will collect all these metrics. There is actually, I think, I'm not sure, does anyone use Cilium or eBPF-based? Okay, so I see one hand. Yeah, I mean, the trick with both things is, of course, you need to manage that stack as well. You don't need to manage your Kubernetes stack, and then you have your application stack, and now you need to have that kind of, and I'm not going to call it middleware, but this the stack in the middle that you have to worry about yourself as well. And in the meantime, I think some of the major cloud providers, I'm pretty sure about Microsoft, they already offer to roll out a Kubernetes cluster which is already eBPF or Cilium enabled. So this won't fall back to the people using it. So you already have that out of the box and can potentially use it. So I really think this technology is in one way or other really taking over the entire Linux network strategy, because it can do things in an easy way, which hasn't been possible before. All right, now final one, the application part. I mean, that looks fairly innocent, this little kind of agent icon within the app, but this is of course a very tricky thing, because starting from that point, things will get application specific. So far we could just like say, okay, I want to talk to the Kubernetes abstraction, or I want to like go on container level, I don't really care what is inside. But now if I want to monitor applications, I also need to be application or like programming or framework language aware. In general, the architecture looks pretty much the same as before. You collect the data, you put it to some database, you visualize it somehow. But the tricky thing is there are quite a few solutions out there. So we have seen Prometheus, Grafana, OpenTelemetry is something I'm going to talk about later. Most of you have heard about an ELK stack in the past, or a combination of those things where you use, for example, Logstash and FluentD to send things into Elasticsearch. Or you can use Zipkin or other technologies for tracing. And this is a bit of the problem here, that a lot of the technologies, they intend to do the same things, but they have like a pretty proprietary nature in terms of their format, how do they collect metrics and how do they collect traces, which makes it really difficult to have them all integrated. And this hasn't been so much a problem in the past. When people were running like big application servers, you could be sure you have that Java stack or whatever, and you need that one agent that could like figure out all the things. But with that polyglot nature that we have nowadays in a distributed systems environment like Kubernetes, it won't work anymore. So that's why I want to put a bit of focus on one technology. I mean, I've mentioned it already before, OpenTelemetry. This is now already the second, like in terms of commits in the open source repo. This is number 2 after Kubernetes from all the CNCF projects. So that kind of tells there is quite a high amount of traction. And when you looked over the agenda here, there were quite a few talks about how to like instrument your Java applications or your applications in general with OpenTelemetry. So I think there is quite a bit going on. So on a high level, how this works, I mean, I should first of all probably say OpenTelemetry is not like a full monitoring solution that would give you all the things out of the box with like beautiful dashboards and stuff like that. So the focus on OpenTelemetry is really to standardize the way the metrics and traces and all observability data is being collected. Yeah, and it focuses on the collection side. So you can see here we have microservices with potentially different application code. We have other components like cloud resources, Kubernetes, and so on. And they have an own protocol called the OTLP, the OpenTelemetry protocol. And the heart of the thing is the so-called OpenTelemetry collector. So with this is like the sink for all the information being collected, which can then help to try to transform or standardize the way the information is collected and then export it to different front ends or other toolings. So this helps that a lot of the, let's say, popular commercial observability providers also jump on that train. I mean, because they are also, of course, being interested in getting metrics being collected, but they can still compete on a level that say, we evaluate things better than my competition. We put, like, we showcase it better, we have better UI, and so on. But for us as users, it's also very beneficial because we're not so afraid anymore, we can't be afraid so anymore because of like vendor logins. Right here, we're definitely not going to show any commercial vendors, so we keep things to an open source level, but that's just some background information for you here. So now, how does this work? This is, of course, an example with a Java application, and we have our so-called OpenTelemetry agent. So now, how do we gonna get those connected? I show that. I mean, you can do that on a process level, very simple. But as we are talking about Kubernetes here, so I thought I'm going to show it how to do that in a container level. So for those not familiar with containers, this is just like a Docker file, which basically is a kind of a batch thing that builds your container. And most of you, I'm pretty sure, have done this for a Java application, where you basically make sure you have a JRE, then you put your code in, and in the end, you basically run the code with your Java command. So the difference here is now, the one thing, you add this Java agent, so it basically downloads it from the OpenTelemetry GitHub site. And then you need to modify your Java invocation. So you need to add this -Java agent right here. So that will plug the jar file into the JVM before your application starts. So you can see this is, of course, a lot more intrusive than all of the previous things, because you have to rebuild your container. And this is the so-called auto-instrumentation version. You don't have to rebuild your application, though. So you can really use your old jar file and just add the other, the OpenTelemetry jar to it. But and then you need to configure that to basically, as I said before, send all the metrics to this OpenTelemetry collector. In this case, this is how I would configure it in Kubernetes. So I specify the values. I have some OpenTelemetry collector being running and available as a service. And this is where the application will then start sending the information to. And if, of course, multiple different applications send their information there as well, then the collector is able to like aggregate and correlate things, and various tools can then later on kind of display it and make it easy for you to use. However, this is not the only way. I mean, you can also plug it into your application already at build time. There's a big flexibility, and I mean, this is an open specification. So you can can totally write your own agent and say, this is the metrics I want to collect, and this is what I want to send, and then it's good. So this is an example for Quarkus. There are some from Micronaut. They're pretty much, I mean, agents for like implementations for all different kind of frameworks. And I'm not going to go through all of them, but it's just the behavior is pretty much identical. You somehow need to get that collection part into your code, and then you can export it to your collector. All right, and once you're there, you suddenly get metrics that would not have been possible, which what we've seen before. So this is like a custom Grafana dashboard that displays metrics being collected from one of the agents. And now you get things like garbage collection cycles and JVM-specific properties that you can display now. So I'm not going to walk all over these, but it's just to show you we're now on the level of the application. Now, one tool I would probably want to highlight alongside of it is called Jaeger. Jaeger has been there before. It's basically a tooling for distributed traces. So you could use Jaeger pretty much without OpenTelemetry, but in turn, Jaeger got pretty popular with OpenTelemetry because it can be integrated fairly easily, and it shows you all the trace information straight away. Now, I said you could use Jaeger before, and this is like an example screenshot from Jaeger, where the agent is not OpenTelemetry, but Istio, like as Tiffany showed before. So you now get the trace information just from like the sidecars. So that means you can only see the entry and the exit statement of a certain component. You don't really know what's happening inside. Now, if you change that to something open telemetry-ish, you suddenly see all the things inside. So you get the breakdown on a class and method level. You see how much time the individual components use. You see the errors. You see where it's being collected from. And that makes it pretty easy then, if you have already identified your slow-running component, basically pinpoint the slow-running method in the end. So yeah, this is just different statement. And I probably should say, this is, from a Java perspective, this is all the things that you get out of the box. So they have like implementation libraries for JDBC, for Tomcat, for Spring Data, and they would normally intercept all the let's say the edge points of your application. For example, a get mapping at a REST controller, or like the Hibernate writing something into a database. However, the standard implementation would not be able to grab your particular individual methods that you have been written. So this is an example. You can see that post mapping on top, where you would write some kind of an item into a database. Normally, I would use that code, like which is commented out, to say, to do a repository, I want to save it, and then hand it over to Hibernate and let it do the magic. But I kind of redirected it to another method, which I just called some useless method, just to make sure this is something that the auto instrumentation would not catch. And you would not see that without it. But then you have this little annotation library, which you can say, I want to annotate this method in a say, I can call this with span, and I'm also going to annotate this attribute here and call it a span attribute. What that will change, that suddenly this some useless method would also show up, which would not have been there before in the first place. And also, if you kind of expand the details, you would also see like the live value of that variable at the time of invocation. I mean, very often you probably have an error that is not reproducible. It just happens every now and then. These are like the tricky ones. So with this one, you can kind of try to filter on the value of the execution and narrow down the problem further from there. All right. So again, we have 2 minutes remaining. This kind of concludes it at this point. I mean, there is a lot of things out there. There's also, of course, a lot of things that we were not able to talk about here. So this is still the old screenshot, but I think the problem didn't change much. So you still have a lot of technologies there that you have to yourself figure out what is right and what is wrong. I mean, in general, we wouldn't want to say this one is better than the other technology. So with this talk, it was more like to kind of categorize them a little bit and to give you a feeling, how much do you need to invest, and not money-wise, but more like resource and overhead-wise, to put that in. How much does it cost you to try it out and remove it again? Some colleagues of mine have built this thing called OpenAPM. This is just a website where we try to list all the various observability toolings, and then you can figure out which is basically compatible to what. So who is able to feed data into what other component, and which combination of things might make sense. This is also open source. We try to maintain it. We hope the companies maintain it, but you might want to give it a look. If you have anything to update there, feel free to do so. All right. Yeah. I think I said all this already, so I'm not going to read through all it again. But this is like the deepest level you can actually go to enable the root cause analysis. But yeah, this is, of course, also the most expensive one. And you need to decide on yourself which parts of the application do I want to do that, or which do I not want to do that. So yeah, I hope we could give you a bit of an overview here. We still have time for a bit of questions. Please feel free to ask anything you like. Also, if you don't have any questions, then maybe we have one, because we definitely want to continue giving this talk and keeping it up to date. So if you see something and say, why didn't you not mention this one? Please let us know, because we would love to integrate it and just try to complete the picture of the observability story. But before the questions, we would like to say...
yeah, I'm going to interject real quick. There's a slide that I forgot put back in here, but basically, those are the slides again that will change to update, which will actually have the other link. But if you jump to, okay, so if you look up our names and you want to see demos of things and are wanting to watch us for 3 hours, there is a deep dive that we did at Devox in Belgium. So if you just look up Devox, and probably actually even the same title, but basically it's 3 hours and actually demoing a bunch of this stuff if you want to see it.
Yeah, that's a good point. We forgot to include that here. Yeah, and it's basically the same talk, but no screenshots and everything done live. So if you want to see one of the tools in a more live level, you can of course jump in and check those talks. And if you don't find it, reach out to us. We can certainly send you the link. And with that, we're going to say thanks for now.